Hello friends, today I am now going to discuss forbidden beta decay. In my previous video, I have discussed about the beta decay allowed beta decay transition or beta decay selection rule. Today, I am now going to discuss forbidden beta decay selection rule, or how can we classify the forbidden beta decay, or how can we identify the forbidden beta decay. That means beta decay is forbidden here. How can we identify that? So let's start discussion about that. So whenever we are going to tell that is a forbidden transition of beta decay, in that case L value should be 1. L value should be 1 means what? That means first forbidden. L value 1 means first forbidden. L value 2 means what? L value 2 means second forbidden. So in this way we can classify it first forbidden, second forbidden, etc. So the main relation between the first forbidden, second forbidden, in this case, how can we classify that? How can we classify? We can classify these forbidden beta decay by a relation. That means that is delta J less than equals L. That is forbidden Fermi transition, Fermi types of forbidden beta decay. If delta J less than equals L plus 1, that is Gamow-Taylor types of beta decay. So let's take an example. Then we can identify that how forbidden beta decay selection rule is working. So let's start that. Suppose you have a nucleus that has J value is what? That J value is 9/2 and parity is plus. You have another nucleus that have J value is what? J value is 5/2 and parity is what? Parity is minus. And electron is emitting and neutrino is emitting. So delta J value is what? Delta J value is here 9/2 minus 5/2, that is 2. So delta J value is here 2. So whenever delta J value, I am taking the mod, delta J value is 2. So in this case, how can we classify that? It will be Fermi types of forbidden transition, or it will be first forbidden and second forbidden. How can we classify that? So we have seen a relation that delta J equals less than equals either delta J less than equals L or delta J less than equals L plus 1. Now one thing I should mention, that parity means how can we classify the parity of a nucleus, that is -1 whole to the power L. So whenever these will be negative parity is happening when L value is what? L value is odd. L value odd means L value 1, 3, 5. And whenever parity is positive, when L value is even, that means L is what? 2, 4, 6, etc. So whenever this L is actually, so whenever here you have got that delta J equals 2. So how can we write this? Delta J equals 2 can be written as delta J less than equals 2. Either it can be written as delta J less than equals 1 plus 1. But now what we should choose? Delta J less than equals 2 or delta J less than equals 1 plus 1? What we should choose? That means I am trying to make you clear that in our nucleus, what was the thing? It was 9/2 plus. From there it was changing 5/2 minus. Electron and neutrino was there, and delta J value what we got? Delta J value we got 2. So what we should tell? It is second forbidden or it is first forbidden? What we should tell? We can tell only by the basis, on the basis of parity. Here one thing you can see, that parity is what? Parity is here changing. Plus parity is changing to minus parity. That means when parity is changed when -1 whole to the power L, when L value is odd. That means L value can be 1, 3, 5, ... L value is odd. That means when then parity can be changed. So here in this case L value should be 1. L value is not here. L value is not 2. In this case, in this case means the case we are discussing. The case we are discussing here, L value is not 2, 4, 6. Here L value is what? Here L value is 1, 3, 5. So we can't write delta J less than equals 2 here, because here L value is 1, 3, 5. So delta J less than equals L, this relation will not be working here. So which relation will be working here? Here we can write delta J less than equals 1 plus 1. Here L value will be 1, because it is satisfying the relation is what? Delta J less than equals L plus 1. It is satisfying this relation, delta J less than equals L plus 1. So we can see from this relation, we can identify L equals 1. That is what? That is first forbidden beta decay. First forbidden beta decay, and delta J less than equals L plus 1 means it is Gamow-Taylor. First forbidden beta decay and Gamow-Taylor type. Let us discuss another example. You will be totally cleared. Suppose, let us take an example. Suppose you have 1 plus, from there you can write 5 plus. Suppose you have a nucleus that is 1 plus, from there 5 plus transition is occurring, plus electron plus neutrino. So delta J value is what here? Delta J value is 4. Now it is what type of forbidden? It is fourth forbidden, or it is third forbidden, because 4 can be written as what? 3 plus 1. 4 can be written as 3 plus 1. As we can see that delta J can be less than equals L also, delta J can be less than equals L plus 1 also. But which one is valid? 4 or 3? It can be decided on the basis of parity plus. It can be decided on the basis of parity plus parity. So let's start. How can we decide? So here minus 1 whole to the power L, parity is what? Parity is plus. Parity plus means what? L value should be 2, 4, 6 dot dot. That means L value can be 4 here. L value can be 4 means delta J less than equals L. It is satisfied, because we can write delta J less than equals 4 here. That means what? That is, it is fourth forbidden beta decay. Yeah. That means it is fourth forbidden beta decay. So that is a case. How can we identify parity? How can we identify forbidden beta decay? So that's it for today. Thank you for patiently watching. Bye.